All right, let's solve this problem that we have using our TI. There's a number of different ways of doing it. The way I prefer doing it in terms of a question where we're taking our certain amount of sulfur. In this case, we've got 0.696. The sulfur is a yellow solid, and this is about 1/4 of a teaspoon of it. So it's a real, less than a gram is a small amount. So imagine 1/4 of a teaspoon of a mass of sulfur. Here's our yellow sulfur, just like I say, a small 1/4 of a teaspoon. And we're going to examine the number of moles and, of course, the number of atoms in it. So I'll do the calculation. I'll take my 0.696, and we've looked this up on the periodic table, 32.07. Oops, I should have divided that. Divide by 32.07 grams per mole. Grams per mole. We always take grams and divide by the molar mass to get the moles. And we've got about 2/100ths of a mole. Always our moles will be a little bit smaller than our grams, because you're always dividing by a number that's greater than 1. So this is 1/32, this original amount. And I'm looking at this number. When you turn a calculator on, don't turn your brain off. You have to think about what these numbers mean. So we're saying, okay, we've got about 1, and then we're dividing it by 32, so we get a value that's less than 1. Now, they want the number of atoms, so we would then take that answer, and you just have to type in times. You don't have to type in this answer. TI is pretty smart. It knows if you're multiplying by that last answer, and I get my 6.022 times 10 to the 23rd, and we'll get a big number. Again, think while you're doing this, because we'd expect a large number of atoms in that 1/4 of a teaspoon. Atoms are extremely small. Even though you've got this fraction of a gram, the number of atoms there are equal to all the bytes in the world. If you could take all the atoms in there and assign them a byte, that would include all the information on the data sphere on the Earth. That's how many atoms are in there. Atoms are very small, but that's why we go to moles rather than numbers of atoms. Now, if you wanted to then find out how many S8 molecules, because these are the individual atoms, and sulfur really forms a molecule. It forms this beautiful ring. And so if we want to count the rings, the S8s, we would then take our answer and divide by 8 and get a smaller number. Okay, think of this, 13 divided by 8, we're going to get a slightly smaller number. 1.6 times 10 to the 21. Again, a huge number of little rings that make up that yellow powder that we have 1/4 of a teaspoon of. Now, if you wanted to do this all in one calculation, you wanted to say, okay, I want to find out the molecules of S8, I would have taken this here. We'll follow this calculation. 0.696 divided by the 32.07. You might say, well, what about the rest of the calculation? No, do this as you go along. The calculator does order of operations as it does the calculations internally. So when it sees this, it's going to take 0.696 divided by 32.07. It's going to put that answer in its memory, and then multiply by 0.6022 times 10 to the 23rd. That'll give us our number of atoms, and then divide by 8. And we'll hopefully get the same answer. I don't like this quite as much because you're not seeing the in-between answers, but let's see if we get this 1.63 times 10 to the 21. Again, a huge number. Oh, there it is, exactly the same value. So in a rule, when you just have simple multiplications and division, and you want to do them all at once, which I don't recommend, you can just take everything, multiply by everything in the numerator, 6.696. You could go on times 0.6002, divided by 32.07, divided by 8, or done 0.6, divide, multiply, divide. Okay, that's how to use the calculator for this. I'll do the next problem in the next video.